Well, students, welcome to my lecture number 33. Here I would like to tell you about the performance of a weeding blade, of different types of weeding blades of a push-pull weeder. Now, you know that in the previous lecture I discussed about that what are these push-pull weeders, and in fact these devices which are manually operated, we cannot keep pushing, we have to push and pull. This way we are in a position to conserve energy and we are in a position to do the work faster. So, these push-pull weeders are widely used. Now, we will see how we measure the performance. What are the various attributes to measure this performance? What is the mechanics behind working with these tools? Let us have a look at this through this particular lecture. See the relative grading of performance of different blades. Now, what is the cutting element? In fact, if you recall in the previous lecture which I have said that the cutting elements are different types of cutting elements which are employed. There is a wheel in front and the wheel is for maintaining the depth of operation and for forward movement, and you have a handle on which the person is applying the force. So, the performance is on what? We will see the performance of that device on the basis of what is the quality of work it has done, how much is the quantity of work that it has done, and what is the power that it has consumed. So, on the basis of the quality of work, quantity of work and the power consumed, we will try to judge its performance, and that is how we have defined the performance of this particular device as this here, where Q1 is the quality of weeding work, then Q2 talks of the quantity of weeding work, and that Pu is the average power used, and K is the constant proportionality, because this performance is proportional to, because the performance P is definitely proportional to Q1 and Q2 and the power used. So, on the basis of this, if we can find out these, we will be in a position to find the performance of these blades. Now, how do you find the quality of work done? This is very important, because this quality of work done has certain attributes in this. See, this PD and PT, see, you know the total number of plants along a crop row length before the weeding operations. We know that what are these? These are, we are talking with respect to how many plants are there in a particular row. So, we have the number of plants. Now, as I told you how the weeding operation is measured, that I talked of the quadrant, whether it is 1 by 1 quadrant, 1 meter by 1 meter, or 0.5 meter by 0.5 meter quadrant. So, that quadrant is the one which tells us how much of weed is already there and what is the weed which is going to be removed from there after the device has been operated in the field. So, here this PD will talk of the total number of plants along a crop row, and the other one will talk of the total number of plants completely damaged. Now, this damage, I must tell you at this point that this damage could be superficial damage, wherein it will appear that the plant has got cut here and there, but it may later period of time it may recuperate and it may not lead into yield loss, and that is called the superficial damage. Now, one is yield critical damage, where it is cut in such a way or maybe completely the plant is cut. So, there that damage will be called as yield critical damage. So, depending upon, we will talk of only the yield critical damage, not the superficial damage, because superficial damage is as good as saying there is not damage, because this will be later on it will revive and the plant will grow over a period of time. So, then we need to know these two, PD and PT over here. So, once we know PD and PT, and of course, 1 minus that, where we do not want that, see PT minus PD, that means there should this should be divided by D. So, 1 minus this will give us what is the quality of work done. Now, this quality with respect to the efficiency. Now, this is the weeding efficiency, as I told you that how much was there and how many weeds were there before and how many weeds are left after the operation. So, the ratio of this, you can see the weeds, total number of weeds present in the two row crops, and then the total number of weeds remaining after the row operation in the same area. So, if you have these, then using this you are going to get to total quality of work done. Now, we want this to be more, this quality of work done to be more. So, more or good quality of work done per unit of power is what the performance we are talking with respect to a particular blade which is used. So, we are only talking in a push pull type feeder, what are the different blades which are employed and which blade is better. We would like to see this and what is the mechanics behind this operation. See, it is worth knowing the operation. You have seen that the push pull type of devices that we are pushing some distance and then pulling it back, not exactly the same distance, but little distance and then again. So, push and pull. Now, how it happens? You can see that if we consider several cycles of such push and pull, then you will get a you can say a stage like this, which I have created here. You can see that this is what you will have. You can say that initially this is the location where your blade is working and the person will be, now this is the position of the blade here. When you operate push and pull, it will have, there will be force which will be acting here, this force F. Now, this force is at a certain angle alpha. So, this P cos alpha, F cos alpha will be acting in the forward direction and F sin alpha will be acting in the backward, in the and directly below. So, what happens is the horizontal direction and this is the vertical direction, particularly downwards. Now, here this will help us in increasing the depth, because then we need to cut these weeds are cut not exactly about 5 or 6 inches, but about 2 to 2.5 or 3 inches or so only they are cut. So, for that this force is a responsibility F sin alpha, and F cos alpha talks of giving momentum in the forward direction. The wheel is there. So, wheel helps us in giving the momentum forward direction as well as maintaining the depth, because if the wheel is not there, then the depth will be varying and it will be difficult for the human being to operate, and that is why wheel has this versions of, because it gives you m r omega square, where it will give forward motion, energy for forward motion as well maintaining the depth. And then these short cycles of push and pull will give us the total speed at which, because it is not possible to measure the speed here just like measuring the total distance in particular time, because the action is slightly different. So, what we have done is we have broken this into small cycles, and these cycles, a cycle one, you can see here that theta I, it talks of the time taken for the ith push pull cycle, where each push pull cycle is 1. So, forward displacement in the ith cycle, say I is equal to 1 to I is equal to 99, I is equal to 100 or whatever, or n. So, forward direction there is a displacement in the ith cycle, then the backward direction in the same ith cycle. So, in cycle in this, so x I f and x I b. So, this x I f, x I b here, that means we will know actually what distance I have moved, and during this period what is the time which has taken during the cycle. You can see it is from ith cycle to as say n cycle. If you are talking of there are n such cycles, say total forward distance t, total time t during a weeding trial is, you can say that the total forward displacement S can be given as this, where S is over a period of cycles from 1 to n, that is x I f minus x I b. And then what is the total time? We have to take the cycles times during the period. Now, this time has to be from the time it has pushed and then pulled back. So, one cycle is completed. So, there is no deduction here, that no deduction here, but it will be the total time theta I, which talks of the time taken for the ith push pull cycle. In one case we are talking of push and then pull, and so the difference is the one which is the forward displacement, but the time here is taken as the full push pull cycle time. So, this is the distance travelled and this is the time taken over here. So, if we know the total quantity of work done, so this quantity of work done is in fact quantity of work done Q 2 is given by W b into S by T. Now, this W b is the work which has been done earlier, and S by T is talking of the time, and eta F is the frequency is the efficiency. So, this total area per unit of time. What will be the total area per unit of time, which we have done already here. So, you can get this here WB and then this. This is what exactly is shown in this case. So, this is the quantity of work done. Now, slight mechanics has been given here to understand, because it is a push pull type of operation, not a continuous push type operation, not a continuous pull type operation. And we know that pulling is better than pushing, but here in this case we cannot move forward by pulling, and that is why we are talking of push pull operation, pushing. Remember that mechanics says that pushing is better than, pulling is better than pushing, because in pushing you are increasing in depth. So, this is decreased, but in pulling what we have, it helps in taking the it goes this sin alpha which has gone below, it goes up when you are pulling it, and that is why it is said that pulling is better than pushing. But in this case, with forwarding we are going forward, and this is the best operation, this is the best mode of operation, and that is why push pull feeder, and that is why push pull type of cycles has been created to understand the mechanics of this. So, we have discussed this. The width of cut, WB talks of the width of cut of the weeding blade, total width of cut of the weeding blade, S is the total forward, T as I said, and field efficiency of the weeder. So, these are the details of how the mechanics of push pull weeder works. Let us go forward and have a look at what exactly we are talking and how we are measuring different type of blades performance. Well, average power used in the weeding operation. What is the average power used? Well, if you talk of the cycles, we have talked of various cycles when we saw in this, that various cycles have been used from cycle I is equal to 1 to I is equal to n. Then average power used in the weeding operation will be, then the average power here will be here. This is the XIF talks of the forward distance displacement, and FIF we talk of the forward force applied. So, force into distance is giving you this energy, and it has to be in the cos alpha direction, because it is talking of the force which we have applied in that direction. So, this component, and then this. Now, this although it is d sin alpha, we are talking in the other direction, but then we have to take care of this d, because we are talking of the total energy, because energy it is here we are not only talking of push and pull, but we are, when we are doing this operation, we are utilizing some of the energy for depth also, and that is why this d is kept here, and the total energy used in a cycle, in the ith cycle say, is given by this. So, over the power we proved for ith cycle is definitely this PUI is given by this, where if we go back to this here, we have talked of the force, that we push force, FIF, backward force is this here, D is the depth operation, a mean angle of operation which we have shown here, and also in the previous diagram I had shown you. Then XIB forward displacement the ith cycle, and XIB is the forward the backward in this cycle. So, using these we are in a position to get the average power employed during nth cycle. So, if there are n cycles, this is the average power here, average power, this talks of the average power, and these are the cycles which have been used, and you can see that say so many of these cycles, if you have added distance, these distances are like this here, then this here, and then this here, like this. How we are adding these small distances, and ultimately we are reaching to the total maximum distance that we have covered and the total area that we have covered. So, this talks of the average power used. So, once we have known these things, we have given the mechanics of push pull weeder. Well, different types of weeding blades. Using this, because we have given what we wanted to do, these are all the push pull type of weeders which are employed, but then different designs are used. Why? Because each has its own advantage and disadvantage. That is why we have given you these different types, and they are named as, you can see the straight blade type B1 here, straight blade type, which is in fact if you have seen a small weeding device manual, this khurpa which was shown to you, it is just this blade which is there, similar blade which is taken about 200 mm. Then this is serrated type. Now, this serrated type helps us in entangled weeds. It is to clear and shear off the weeds. It has a given 15 degree this sharpness angle and 20 degrees the cutting angle. So, each has been maintained by that. Now, here there are 5 tine blade. There are 5 tines of blades. They gave some sort of earthing operation, where you find that the weeds are not that much, but then you would require to remove the upper crust, so that the aeration takes place. The soil will start breathing, which is essential for the plants to grow at that moment. So, there we have found that these ones are very good. The and in fact, out of these two, this is another sweep type one, where at 200 mm again, but then these are all of the same size, but different different shapes, etc., depending on where they are used. So, these ones give us you can say that where the row to row spacing is slightly smaller, and there you want to go in between and cut. Now, this is the one which has something in similarity to this, but then it also puts the soil onto the plant, which when it is operated in between the row crops, what will it do? It will put the soils on the side, on the beneath the plants, and that is why this is advantage over there. So, all these 5 types of tines have been used. They have the same width, they have same cutting angle and same the sharpness angle. Now, but there are various ways. Now, out of these we would like to find out which one is best for our operation. This is what is the job for this particular lecture that I want to explain to you. How do we do this? How do we measure these forces, etc., which I talked of, but how do we measure the force? So, we developed, this is one which we have been developed at IIT Kharagpur. See, in fact, then here you can see here that there is a device here, there is a bevel gear arrangement in this small wheel, then this is the front wheel of the weeder, this is the tine which has been kept here, and this is a graph. And some arrangement has been made that the moment there is a pushing of this, the graph will move on to this. We are maintaining an angle of 48.56 degree. The H is the inclined handles total length here, then the recording needle, N is the recording needle over here, this is the recording needle which works in this case, then compression ring spring, there is a compression spring which is here. In fact, this is the location where the compression ring is the compression spring is kept. Then transport wheel, of course, W is the transport wheel. Well, while we say that this is transport wheel, but then remember what we have done. In fact, this has been modified, the weeder, the push pull weeder has been modified into a measuring device, force measuring device. So, you can see here that everything else is there. What we have done, we have used this portion and we have used this portion, by which we are in a position to measure what is the force required for operation of this particular one. So, this is a device also developed at our place, and in fact, you will find my paper published long back, and you will find the details of this unit which has been used since then. Is not available, but we have made it long back and then published, and it is being used. You can see more details of this unit. So, this is the way we are in a position to get the force. How it comes like that? What is the way by which we see that this force is available, and we are in a position to use this? We will see in next slide. Well, this is how it looks. You can see that this record which we have got, this is the record which we have got here. This record looks like this. You can see any blade, B1 blade. Now, this blade is there, and you can see here these are talking of how forward and backward movement. You can see forward and backward movement. Straight one of the blades, just in order to show you that in one of the blades what were the particular graph that we got, we have shown you here. You can see that the forward looking force is higher than it is pulling it. So, while pulling, you are not exerting any force except that you are pulling the whole thing back, and since the wheel is there, it is easier. So, that is why you will find that in each case you can find that these are the small portions where you are applying the virtually the force for pulling back, and these are the front ones. So, you can for a particular blade. So, this is the inside on this particular graph we are getting something like this with a particular type of blade. Now, so if we change this blade, we can find out this particular graph and hence the force. What we wanted there is the power requirement. So, in order to get the power requirement, we wanted to get the force as I have discussed earlier. So, where to measure the force? So, we have had this device developed and then we have measured. It looks like this on the graph, and from this graph we are in a position, as you can see here, we are in a position to measure what is the force, because we know the spring constant of this particular spring. So, we are in a position to find out how much is the deflection accordingly of this, and then we can say how much is the force over here. Well, Weeding force during field trials. So, different field trials were done for with these devices in the actual field conditions. These are done under actual field conditions, I can tell you, and we have here the different blades. The different blades are here B1, B2, B3, B4 and B5. Different blades are available with us, and in these blades then I have already shown you what are the types and where they are used and what are the different features of those blades, how they are beneficial in a condition, so on and so forth. And we have talked of we showed you that only 200 millimeter is the width of cut of each one of them. Now, in this we have employed two types of these with two widths. One is 15 centimeter, that is 150 mm, and the other is 200 mm or 20 centimeter. So, with this we have measured all the details. You can have a look at this, what we have measured: the mean weeding force per cycle, 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 mean weeding force per cycle for each of these B1, B2, B3, B4, B5. This is what we have measured. What we got here? We got these values, you can see here. You can see these values. This the ones which are given, these are the possibly the variations, standard deviations here, which are given from there, because we are talking of the mean weeding force. So, from the mean, these are in the brackets we have given the standard deviations. So, mean plus standard deviations in the brackets given here. So, we can see that B1, B2, B3, B4, B5, and if you see the n by centimeters, that is this force, we can see here this, then this here, then this here, then this here and this. In fact, these A, small a, c, c, etc., because we had used here Duncan's new multiple wrench technique, DNMRT, which was used here. DNMRT, Duncan's new multiple wrench technique was used for comparing the means. This is a technique which is available, and that technique I had used at that time to compare these mean values of B1, B2, B3 and B4. So, the ones which are closer, that means they are very close to this. Ones are varying, that means they are markedly different from those values. So, there is a difference between this. So, statistically we have also found out whether the values which we have got for B1, B2, B3, B4 and the values which we are comparing, they are how close statistically, and that is why we use this statistical test to find out these details for the two types of the weeding, you can say width of cut of these blades. Field testing with different blades of a push pull type weeder. Now, we have used this weeder 15 centimeter wide, as I told that we have used for 15 centimeter, and then we are talking of one for 20 centimeter. So, we have used all the details. What are those details? If you see, we had talked of the performance. When we are talking of the performance of this, in fact, we are talking of, see, man days per hectare is one consideration, just to have it and look at it. You see that man days for B2 we require 24 man days per hectare, then B3 we require 19, and B4 18, B5 18, and B1 we require only 16 man days per hectare. Field efficiency, we can see that field efficiency is also higher in this case as compared to the other blades, 62 here, 67, 70 and 71. So, the field efficiency is also here higher in case of B1. Then weeding efficiency, see very high level of weeding efficiency which we got in this case, that is also very high. Quality of work done is a good quality of work done. Using the same formulae which I had given earlier, we are in a position to do this. Power consumed, well, this is the power consumed here, and performance index, see this is the one 0.082. Although for B2 also we got 0.082, but then you can see this here the power consumed is higher as compared to this, and therefore, we can say that at 15 centimeter wide row here, the B1 blade is giving better performance. Now, it depends on when you are thinking of different types of situations and conditions in which those blades, because I have described why a 510 blade or a 310 sweep or this or a width or a particular type is used. They have their requirements in different conditions. We have compared here for one condition, and there B1 is found to be the best, but then all these need to be operated under varying conditions. So, you can see that the performance of all these are here as compared to B1. In a condition they are disadvantageous, but otherwise they need to be operated. So, at 15 centimeter width, this is the operation over here for both, for all of them. This is B1 is a straight flat blade type which I have shown you, B2 is a straight flat blade type with serrated edges. This then B3 is 510 blade, B4 sweep type of blade, and 510 double plow type of blade. Very nice. Sometimes as I told earlier that this helps in putting up a little bit of earth onto the roots of these particular plants, which is helpful particularly in say orchard crops or in vegetable crops like potato and all that. You would like to put some sort of, so there this will be very beneficial. Now, you can see at the 20 centimeter wide, a similar situation we see here. If you compare the 15 centimeter width and 20 centimeter width, in the same condition we find that B1 is advantageous. Well, one may think that I am biased towards B1, not so, but in the condition in which B3, B4, B5 all were used. Now, if they are used in say a condition which is suitable for B5, then you will find that B5 is giving better performance as compared to B1, B2, B3. So, although in a given condition we find that B1 is better, see for all these parameters, man days per hectare 15 here, 22 here, 16, 17, 18 here, then field efficiency is higher here and all less are lesser than this. The weeding efficiency is also very high, the quality of work done is also very high here. This is one because this has straight blades. The serrated ones sometimes they leave the blades and not particular sharpening is taking place. That is why you find, but the quality of work done for B1 is very high. The power consumed is less also. You can see here in this case with 20 centimeter wide, we do not find that difference which we were seeing earlier, that the performance was better, performance index. So, performance index is 0.09 here, or you can say that maybe 9 out of 100 we can give here. Possibly we are talking with respect to the performance, mostly with respect to how much of the quality of work, good quality of work done we got per unit of power that we have utilized. This is what is the one which we are more interested. So, as such, now in this particular lecture what I wanted to show you is that a push pull weeder when added with different cutting elements, the cutting elements are those blades which have been used of the same size, but of different configurations. And of course, each one has its own applications and suitability in different conditions of the crop, or whether it is a orchard crop or a cereal crop, depending upon what it is, you will find that each has its advantage, and that is why all these were tried, and we have found out the performance of them. We have found out a mechanics of cutting of push pull type weeder, which can be utilized anywhere. It is also published, as I said, and I think we have in a position to give you the mechanical weeding as such, and we have talked of now we will talk of the advanced level of mechanization, particularly for these operations in our next lecture, where the idea is to use advanced technology for minimizing the inputs and maximizing the outputs, because we are not getting labor, etc. And that is why up to this we have considered the mechanical, biological system and flame weeding, etc. And now we will talk of the advanced level where sensors, electronics and mechatronics things could be used. That will be taken in my next lecture. And if you have any questions, etc., we are very open. You can send us details to us, and we will be in position to answer to you. And I will thank you for this particular. Thank you.